or minus 13.
Very good. I completely agree. So Rachel started with these two terms because they are the most powerful ones. And she said 2 apples plus 5 apples is 7 apples. Then she moved on to the terms with power 1 for x, for the variable. Negative 7 plus 15, she said 8x, that's perfect. And then finally she went to the free terms, where x has power 0 actually. So 7 minus 20 is negative 13. So the degree is 2, the leading term is 7x squared, the leading coefficient is 7. Any questions on how to combine like terms? Any questions on how to combine like terms? Okay, in that case, let's move on to subtracting. For example, 4x to the third minus 3x squared plus 5 minus quantity 13x to the third minus 8x plus 14. In front of the first group, or grouping symbols if you want, there is nothing. By there is nothing, we mean it's positive 1. We don't write it, like here, positive 1. We don't write it, but we know it's there, which means there is no change inside the grouping symbol. I have to copy 4x cubed minus 3x squared plus 5. But now I have to be very careful because in front of the next grouping symbol, there is an imaginary negative 1. So, what do I have to write?
Second part, is that minus 8x or minus 3x?
Here?
No, the next one.
Minus 8, sorry.
Okay.
Sorry. So we need to distribute negative 1 to all 3 terms that we see in parentheses. So negative times positive is negative 13x to the third. Negative times negative, however, is positive 8x. But negative 1 times 14 is negative 14. This is a mandatory step. Only now I'm ready to combine like terms, find the degree, the leading term, la la la, la la la. So I'm ready when you are. What do we write?
Nine x cubed.
Careful, is not negative, yes.
Oh, yeah, I'm sorry.
Perfect. Now,
minus 3x squared.
Yes, because 3x squared and negative 3x squared cannot be combined with anything. There is no like term. Very good.
Minus 8x.
So it's positive.
Plus 8x.
Yes. And then we do have these free terms that are like terms, and we have negative 9. Good. This is the resulting polynomial. As you see, it has 4 terms. It's arranged in descending order. It has a leading term, negative 9x to the third. It has degree 3. And it has a negative 9 as the leading coefficient. Do we understand how this works? Combining like terms, presenting in descending order, adding and subtracting. Is that a yes? Do we need more examples? Please don't be shy. Speak up, please. Okay. You can stop me anytime. Notation. We have different ways of giving names, if you want, to these polynomials. So one notation is P not P multiplied parentheses X. No, we read this P of X. What does this mean? It means that X is the independent variable, and this is the dependent variable. Meaning also that if I say P of X equals 3x squared minus 2x plus 1, it also means this, that I gave this expression the name P, or it can be F, or it can be T, it can be W, whatever you want, any name. But in parentheses, I put the independent variable, meaning this is what you should expect to see inside as the variable, as the independent variable. What if I have F of A? F of A means, let's say, negative 2A plus 4, which means expect to see the variable A inside this expression. And I decided to call it F of A. The name of this expression is F. The variable you should expect to see in here is little a. And we can go on forever. I can have P of V. I can have T of T. I can have any name we desire. Okay. Now, why is this important? Because after understanding the notation, we're going to look at evaluation. Evaluating polynomials. I'm going to start with this very simple example. Let's say I am discussing this polynomial. I can tell you a lot about it. It's a binomial. It has degree 1. It has a leading coefficient negative 2. It has a leading term, negative 2a. I can go on forever. But what is very important here is something called pattern. And you can say, what are you talking about? Well, if you give me this expression that you denoted by f of a, this is what I see. This is the pattern. Meaning, this polynomial that you denoted or we denoted by f that has the variable a in it follows a particular pattern, which means whatever you want to put in here, let's say I want to put 55. It means that you have to multiply 55 by negative 2 by the order of operations. When you're done, you are going to add 4 to it. And this is how I evaluate a polynomial. But first, I need to understand the pattern. Again, the pattern is negative 2 times whatever you want plus 4. That's the pattern. What is the pattern here? Okay, 3 times whatever squared, then minus 2 times whatever you want, and then at the end you end 1. So the pattern for this is the following. Now you can plug in anything you want. Let's say I want to plug in 0. Fine. Let's say I want to plug in 10. Fine. But I have to follow the pattern. I cannot pick and choose. If it says 3 times whatever squared minus 2 times whatever plus 1, this is what I have to follow. I have to follow the pattern. Is there an easy way to evaluate? Yes. Although I'm going to evaluate it by hand as well, we're going to also do it with a calculator. So let me show you how to do this with a calculator. And you should be able to do it because it's important to check your answers before you enter them. Remember when we solved equations, I said, please don't enter x equals 5 before you check in the original problem. What's the point in losing points? or getting a low grade by simply not checking, which takes 3 seconds or 10 seconds or 15 seconds. So here's how we do this, evaluating. I have a video from the other class. I will post it. If you want me to record this, I'm going to ask you to turn off your cameras and I can record this. You choose. Okay, so Rachel turned off her camera, so I'm assuming that everybody did the same. Let me check. So I will record this. Excellent. Perfect. Okay, let me see, where is my record button? Okay, under more, record, record. Okay, so in y equals, I clear whatever I have, and I enter my function. If we start with a negative number, we have to use not the operational negative, but this little white key, the negative. 2, this is the key for x. We don't have A or B or C or whatever else. We have X in the calculator. And then plus 4. Now make sure that you go first to second and right here, table set. Second table set. And make sure that the table start, it doesn't matter. You can have anything you want in there. The increment, delta table equals 1, it doesn't matter. But the most important thing is scroll down, go to the independent variable and make sure that it is in the ask mode, not the auto mode. The auto mode will not allow you, the calculator will not allow you to enter the numbers you want. The calculator will start whatever here and will give you only the possibilities of based on the increment. You don't want that. You want to have the independent variable in the ask mode and the dependent variable in the auto mode. That's okay. So then I go back to second and table now, right here, and I put in my numbers. So I chose 55 and press, and I get negative 106, sorry. So the answer is negative 106. Now, in order to go back, go to y equals, clear, and I want to enter the other function, which is 3x squared, or polynomial. Minus 2x plus 1. That's the pattern. I'm entering the pattern. And now I can enter anything. It was negative. So now I can evaluate for whatever I want. So let's say I want to evaluate for 10. So I punch in 10. And I get 281. Good. Now, do I need a calculator? No. Should I check? Yes. So then f of 55 is negative 2 times 55 plus 4. First, I have to multiply and then add 4. So I get negative 110 and then plus 4. And I have to get the negative 106 that I already determined with the calculator. For the previous one, for p of x, so I decided to evaluate for 10. So I have 3 times 10 squared minus 2 times 10 plus 1. By the order of operations, I have to square first. So this is 100 times 3 is 300. Negative 2 times 10 is negative 20 and plus 1. 300 minus 20 is 280. 280 plus 1 is 281. And that's exactly what we obtained with a graphing calculator. So this is how we evaluate polynomials. And this is why we like to name them. Because what is my other option? My other option is this, a lot of words. I'm giving you an expression or a polynomial that is 3x squared minus 2x plus 1. And now I'm asking you to evaluate it for 10. But here is so much simpler. Find P of 10. Instead of saying, take this expression and evaluate it for x equals 10 and give me the answer. No. Very clear, very short. Find P of 10. That's why we like to name them, and that's why we have ways of determining their values or evaluating them much faster. Any questions on evaluating? Any questions on evaluating? Okay, a long time ago, if you remember, I said something like, okay, what if I have 2x divided by 3? What I would like you to understand here is this is the same with this. This is extremely important. It's not the same with 2 over 3x. X is in the numerator. It cannot be in the denominator. So it's not the same with this. But 2x over 3 is the same with 2/3 times x. If you understand this, your life will be much easier whenever we have to add or subtract polynomials that have a coefficient or coefficients that are fractions. So here's an example. Let's work on this. 1/4 x to the 5th plus 1/2 x to the 5th minus 8x plus 14. Well, obviously there is nothing we can do here. We only need to add these two. So in this particular case, I have to find the least common denominator. I cannot add them without the least common denominator. But we've done this before. We know how to add fractions. We know those 3-4 possibilities of finding least common denominators when we need to. So what is the least common denominator here?
4.
Yes, the least common denominator is indeed 4. And I already write x to the 5th. I already copy negative 8x plus 14. Remember, there is no two negatives. I write like this just to make sure that you understand once I write a negative sign here. If I don't, you may say this is it, it's done. But I wrote a negative sign. There are not two negative signs. It just says follow through. Something else follows. Good. So if the least common denominator is 4, then we need an adjustment of 2 here. 1 plus 2 is 3. So I don't want you to get confused if this or both are written like this. X to the 5th over 4. This may be confusing to some, but this is the same thing with this. It's 1/4. There is an imaginary 1 in front. 1/4 x to the 5th. Let's look at another example. Any questions on this before we look at the next one? Okay, so let's move on to, this is my page 5, no, it was my page 6, right? Yeah. So here's an example. 5/4 p squared minus 3/2 p plus 6 to subtract 1/12 p squared plus 5/6 p and plus 5. So let's work on this problem for 1 minute, please.